What are you doing, dude?
I don't know.
Are you really trying to use Notepad for coding explain data refs?
Yes? Is there a better way?
Yeah, of course there is. Just use MobiFlight. It's free and it works. Type in MobiFlight and open it.
Oh, this app.
Yeah, and then you just need to click the run
Yes?
and it basically works.
Whoa.
Go into explain and try.
So, if I do a light test. Whoa!
Works. Just use the MobiFlight and don't use Notepad custom goals because that is not going to work.
And actually, Artturi is right now showing you how to use MobiFlight.
Let's get into it. Alright, and welcome back everybody to the DI Fin channel. And my name is Artturi and I'm here to continue where Aapo left off last time. So the PCB is now all wired up and soldered in. I did have to do some minor modifications to the buttons, as you can see. They are rotated 45 degrees, but they serve the exact same purpose. The PCB just had a slight flaw in it, but nothing has changed, and the PCB is now physically done, and next up is the code. And to connect this PCB to a PC, you need the ribbon cable to connect to the Arduino, what was done already in the last episode. And the Arduino needs to be connected to the PCB, to the computer with a USB, just a regular USB. Also, our design includes or needs 12 volts power to power the LEDs and the controllers. And that in test one will be powered by this DC power supply that will simply power the PCB's power through the Arduino. It's kind of an interesting setup, but it's powered through. So that's sort of the setup that you need to go get before you can start to actually code. But when you have this done, we can hop into MobiFlight and see how the configuring and coding is actually done. So let's go ahead and move on to MobiFlight. Alright, so here we are in MobiFlight. Now, if you don't have MobiFlight installed yet, and you're completely new, you can download MobiFlight on their website, mobiflight.com, and here you can just install the MobiFlight connector, which is also the software that you do all the coding in. Just download the recent version here and follow the instructions. It's very simple and it doesn't need explaining more in this video. And then another thing that you will need, because our panel is a little bit more custom than maybe the most basic panels, you will also need a script sort of platform called Fly with Lua, and this is for Explain 12. Just download the GitHub repository here, download zip, and you need to install it into the Explain plugins folder. It will be the Fly with Lua, and this will be the contents. Another thing that you need to do when you install Fly with Lua is go into scripts and delete the script that is in here, because that is just a test script and it prompts an annoying bubble into your screen when you start. So you need to delete the script here. But now let's get actually in the MobiFlight when you have it installed, and this is what you will see. And it's just a blank page with nothing on it, and this is what we will start to populate with our configuration. Alright, so the first thing you do in here is click on the MobiFlight modules, and it opens a window, and here you can see all the Arduinos connected. Another place where you see your connected modules or Arduinos is in the bottom corner here. So if you close this, you can go here and see that at COM port 4 we have a Arduino. Now it doesn't show as this name when you first plug it in, because what you need to do is click update firmware, and that uploads the MobiFlight firmware in, and that way you can actually start to upload your configurations in. But when you have the firmware uploaded onto the Arduino, you can start to add devices, and you can see I already have 2 devices, but basically you just click add device, and depending on what devices you have, you select the corresponding device in this list. In our case, we will be using a multiplexer, and in our case we will add a digital input multiplexer, which is the multiplexer that we use. And here you will choose your data pin, so what pin the multiplexer data pin is connected to, and you will see this, or that this pin will depend on where you have the cable physically attached. And here you can select how many bits, so how many pins the Arduino multiplexer has. So 8 or 16, we have 16. You can give it a name, or you just leave the default name. And here you can see the address pins, and these are common among all the multiplexers. So you can see that we have defined them in here, but this will again depend on where you have specifically put on the pins. But setting up a multiplexer is very simple, and this is something that we use a lot to save on pins on the Arduino. The same thing goes for the LED controller. It's a shift register, and here again you just find your latch clock data and select how many bits. In our case it's the 16-bit again, so 2 8-bits, and give the name or don't. It's very simple. What the latch clock and data are again depend where you have plugged them in, but now I would have to make sure somewhere, but I believe you can chain the latch and clock pins on shift registers, but don't quote me on that. It might not be the case for MobiFlight, but I would have to make sure if I were to promise this, but you might be able to chain these or put it on the same pins. Not sure, maybe. But this is how you add the multiplexer and shift register that we use in our custom PCB. You could add just regular buttons, encoders, potentiometers, and LEDs, 7-segment servo steppers, whatever, here individually. But in my opinion, using multiplexers and shift registers is way more a professional way to do things. You don't need to use so many wires, cables, pins to do the same thing. So when you have all your devices configured, pins selected and devices added, you just click upload config and it uploads the config that you have made here. If you don't click upload config and just leave, it will not save, so you have to remember to upload the config, and usually you would want to save this somewhere so you don't lose it if your Arduino breaks or something else happens. I have it saved. Alright, let's make a save for this tutorial. We can show ADFS Captain setup test, and that's how you save, and then you can just leave. And now we have the Arduino setup. We can start to actually add output configs and input configs, and there is an obvious difference between output and input configs. In output you will have everything that goes out from your computer, from your simulator, to the Arduino, to your PCB, and those devices would be LEDs, 7 segments, stepper motors, servos, LED matrices, and all of those things. And then in the input configs you will have everything that goes from your PCB to your PC to your simulator. Again, for example, encoders, potentiometers, switches, buttons, and multiplexers in our case. But in this tutorial will start from the output configs.
But before continuing, we would like to tell you a little more about our sponsor, PCBWay.
PCBWay is a part manufacturer who offers PCB manufacturing and assembly, CNC machining and 3D printing services.
Their low prices and endless customization enables everyone to use their services in a moment's notice.
We have already ordered some parts for this project and it was very convenient and easy process.
Go check them out from the first link in the description.
Thank you PCBWay for sponsoring this segment. And back to the video.
Alright, so how do we add our output config? Double click here as it says and give it a name. How do I give names is I check what I named it in the schematic. We want to configure this first. So LED AP1 will be the name. We'll go here. Sorry, not here. That's explain. Go here and give it LED AP1 as name. Click enter and it's done. Then we click on the three dots on the very right side and we are faced with this screen. Here you don't need any sim variables, you don't need any modifiers, but you do need to do display. Here you can see our output, our input device. We will obviously be using an output device. This is the Arduino and use type is a shift register as we configured on the MobiFlight module. And we will use the only shift register that we have, which is named LED controller, and pin will be, let's say, number 1. Well, no, actually, you can't just select output 1. You'll go here, LED AP1, and you will see that LED AP1 is on pin 0, so the first one. So then select 0 and it's done. So this is where the command will be sent. Then you will go in the sim variable. Depending on what simulator you will use, you will select one of these 4. We'll be using explain 12 and then you select this one. Explain uses data refs, which are the kind of lines of or strings of code that control and display data from the simulator. To find what code or data ref we'll need to use, we need to either know the name or find the name. Obviously the names are not something that you can just type in here. The name is not going to be AP1 like I have named it. It has to be a specific name that I explain or a specific mod that you're using has named. In our case, I don't know the name, or I do know it, but let's pretend I don't know. So we'll fire up explain, and in explain there's this clever tool or plugin called dataref tool. The link will be in the description if you want this tool. This is a very useful tool for locating data refs. Just put it in the plugin folder and it should work. Click on the search and it opens this window. I already have it open right here. And in here you can select search for data refs. So I have already searched for AP this because that's what I expect the name to be. Why? Because this LED is the autopilot disconnect annunciator. Now to make sure that that is the one is where the dataref tool comes in handy, because when the LED is activated, so when I disconnect the autopilot, the light will start to flash and you can see that the dataref will start to flash as well, to 0 to 1. This is the value. 1 and 2 is captain 1 and first officer 2. And the one with no number is the common, which would control both. But in our case, we are wanting to use the captain side. You can click copy name, and we can stop the blinking. And go in MobiFlight with the copied value. Paste it here, and it's right there. You can click OK, and that's your first device configured. To test if this actually works, you can click run, go into X-plane, make the LED flash again, so we'll do this, and there we go, it is flashing. Now you can see that it is flashing orange and not red like in the cockpit, and that's because I have accidentally selected the wrong pin. So let's go ahead and change the pin in MobiFlight. We go into here, go edit, don't mess this up, go into display, and I expect it to be output 1 instead of 0. Click OK, and there we go. It is now blinking red. I'm not going to go through every single LED because that process goes exactly the same for every single LED. So what I'm going to just do is show you the end results with all of them configured, so that we can get moving on. And this configuration will be available for free. Join in the description, and you can use and download this as well as the BCP files, so that you can create this yourself. Alright, here we are again. Now I have all the LEDs done, and you can see when I run, and I go into the simulator, and I flip this test switch, all the LEDs turn on, and you can actually see the power draw. It draws about 58 milliamps, which is fine for all of those. And then click down, and it only lights up those. And that's how it's designed to be. But obviously, we don't want to be clicking with our mouse, because that's stupid. So let's go ahead and get all the buttons that we have in here, and the switch that is connected into this wire right here. Now, to do input, the config input, in this case it is a little bit more difficult, because as it turns out, when we go into X-plane and go into here into the data refs here, we can find the buttons that you can click here, called button slash AP, and you can see that this data ref is the button. But if we go and view what the data ref description is, we can see that it is not writable. What this means is you cannot write this specific data ref, and that is a problem, because writing means changing the status using an external device such as a tactile switch that we would be using. How do we overcome this problem when there is no data ref available? Is using Lua script interface. Now, before this video I was not very familiar with a Lua script, so what I did was hopped into Discord. I noticed that a lot of other people have had the exact same problem with the AFDS module, where they cannot find a data ref for a writable data ref for the buttons. So what I did was went there, and there was a dude who had conveniently made a Lua script that I can show you. In Fly with Lua script has a script that adds these data refs. Now, you don't really need to understand too much of what this code does. I don't exactly understand it myself either, because I am not very familiar with this yet. I do plan on learning Lua scripting, and this is just simple coding. But you don't need to understand too much. This script will be available, or I'll at least have a link to where you can find this on the Discord server. By using this script, you will be able to access those missing data refs that you need to have a fully functioning ADFS unit, or sorry, AFDS unit. So all of these are the data refs. Just what you need to remember or realize is these are the data refs that you are going to be using now. So for example, we can copy the MobiFlight / Boeing 737 / pilot AP press, and then associated with this is also the release command, which has to be also created, called exactly the same, but pilot's AP release. These two are associated with each other, but just take one at a time. Copy this. We'll go into MobiFlight. Give this a name, AP1 tactile switch is what I give it a name. Go ahead and edit it. We can go ahead and scan for input, and this is now looking for an input on the device. I can click the button that I want. I click a button and it recognizes it as multiplexer pin 2. So that's the third pin since we are counting from 0. And here we can do on press, explain variable, preset code, and this is important, command, and copy the data ref here. Now you can see this is on press, so on release, again explain, and here on command we can just copy this, and I can just type in here manually release, and that's the data ref. And nothing else needs to be done here. Just click OK, and we can run this like this. Go into explain, and if you make the light blink, it's now blinking. And if I now press the button, you can see it clears the error. And you can also see on the data ref tool over here, but when I click the button, it writes the value in there, and it highlights the data ref. I do not know why this data ref is made not writable, and why do you need a Lua script to make it writable, but that Lua script is how you make it writable, and that's just a stupid way it needs to be done. So now exactly the same for every single button, and this which differs doesn't differ at all. So I am going to show you what the final config looks like. I can do open. We don't have to save this. Click in here, and here we have all our outputs and all of our inputs, and we can take a look at the light test switch number 1, and this is exactly the same. Here is the command data ref and release data ref and pins, and everything selected like this. So coding in MobiFlight might be a little bit overwhelming at first. There's a lot of things, a lot of text fields. It's not exactly intuitive in every case, but it is easy to learn when you just put a little bit of time, watch some tutorials, and get help from MobiFlight Discord, or you can ask me help in the video description down below, or in my Discord server in DIFIN Discord server. I'll be happy to help. We will be happy to help. But essentially, this is how the code or configuring in MobiFlight works, and it is good to know that also our PCB works. In the future, we are going to be showing you how to do things like 7 segments and servos and stepper motors and much more. So stay tuned for all of those kind of tutorials. We are excited to test those things ourselves because we do not yet ever have used MobiFlight for servos, 7 segments, etc. But we're excited to get experimenting with those as well as making the PCBs. So stay tuned for that. This is for our AFDS panel video series. The panel is now done and everything works. So thank you so much for watching this series, and if you have any questions, as I said, go into our Discord server or down in the description of this video. Ask anything away, we'll be happy to help, happy to answer, and we'll see you in the next one. Goodbye.